Yes, magnetism can occur in MC cable when looping 2 feet of slack at each end of a run going out to 277 volts high bay light fixtures. MC cable, or metal-clad cable, is a type of electrical cable that is constructed with a metal sheath typically made of aluminum or steel. This metal sheath provides protection for the inner conductors and also serves as a ground path. When current flows through the conductors in MC cable, it can create a magnetic field around the cable. The magnetic field strength around the cable is directly proportional to the amount of current flowing through the cable. Therefore, the more current that flows through the cable, the stronger the magnetic field will be. In the case of a 277 volts high bay light fixture, the current draw can be quite high, especially if the fixture is using metal halide or high pressure sodium lamps. This high current draw can create a strong magnetic field around the MC cable that is feeding the fixture. A magnetic field around the MC cable can induce currents in nearby metal objects such as the steel support structure of the building or other electrical cables. These induced currents can create additional magnetic fields which can lead to interference with other electrical equipment and systems. To minimize the risk of magnetic interference, it is important to properly loop the MC cable at each end of the run. The loops should be made as large as possible and they should be kept away from any metal objects. Additionally, the MC cable should be secured to the support structure using non-metallic straps or ties. By following these guidelines, you can help to minimize the risk of magnetic interference and ensure the safe and reliable operation of your electrical system. Understanding the principles behind magnetism in electrical cables is important for electricians and electrical engineers. Magnetic fields are created by the movement of electrical charges. In the case of AC circuits, the current is constantly changing direction, resulting in a fluctuating magnetic field. This fluctuating magnetic field can induce voltages in nearby conductors, which is the principle behind transformers. In MC cable, the conductors are enclosed within a metallic sheath. This sheath can act as a shield, reducing the amount of magnetic field that escapes from the cable. However, if the cable is not properly installed or if there are loops or bends in the cable, the magnetic field can become concentrated in certain areas. This concentration of the magnetic field can lead to increased interference with other electrical equipment. Firstly, the size of the loop is a critical factor. Smaller loops tend to concentrate the magnetic field more than larger loops. Secondly, the proximity of the loops to metal objects can also affect the amount of interference. If the loops are close to metal objects, the magnetic field can induce currents in these objects, creating additional magnetic fields. Thirdly, the type of metal used for the sheath can also affect the amount of shielding provided. Steel sheaths generally provide better shielding than aluminum sheets. To minimize magnetic interference, it is important to follow best practices for installing MC cable. One important practice is to make the loops as large as possible. This will help to distribute the magnetic field over a larger area, reducing the concentration of the field in any one location. Another important practice is to keep the loops away from metal objects. This will help to prevent the induction of currents in these objects. Additionally, it is important to use non-metallic straps or ties to secure the MC cable to the support structure. This will help to prevent the cable from coming into contact with metal objects. In some cases, it may be necessary to use shielded MC cable. Shielded MC cable has an additional layer of shielding that helps to further reduce the amount of magnetic field that escapes from the cable. This type of cable is typically used in sensitive applications where magnetic interference is a major concern. When working with MC cable, it is also important to be aware of the potential for electrical shock. MC cable is typically grounded, but it is still possible to get a shock if the cable is damaged or if the grounding is not properly installed. Always use caution when working with electrical equipment and follow all safety procedures. In addition to magnetic interference, MC cable can also be affected by other types of electromagnetic interference or EMI. EMI is a general term for any type of electromagnetic disturbance that can interfere with the operation of electrical equipment. EMI can be caused by a variety of sources, including radio transmitters, cell phones, and industrial equipment. To minimize the risk of EMI, it is important to use shielded cables and to properly ground all electrical equipment. It is important to understand the specific requirements for electrical installations in your area. These codes provide detailed guidance on how to install electrical wiring in a safe and reliable manner. It's crucial to consult with a qualified electrician or electrical engineer. These professionals have the knowledge and experience to design and install electrical systems that meet all applicable codes and standards. They can also help to troubleshoot any problems that may arise. When dealing with electrical installations involving MC cable and 277 volts lighting, several important considerations must be taken into account to ensure safety and code compliance. Firstly, conductor sizing is crucial. The conductors within the MC cable must be appropriately sized to handle the current load of the 277 volt high bay luminaires. Secondly, overcurrent protection is necessary. Circuit breakers or fuses must be installed to protect the circuit from overloads and short circuits, and these must be properly sized for the specific circuit. Thirdly, grounding is essential. Proper grounding of the MC cable and the luminaires is critical for safety. It provides a low impedance path for fault currents, helping to prevent electrical shock hazards. Fourthly, secure connections are vital. All electrical connections must be made securely and in accordance with the NEC or National Electrical Code. Loose or improperly made connections can cause overheating, arcing, and even fires. Fifthly, support and securement of the MC cable must be properly installed. The MC cable must be supported and secured at appropriate intervals to prevent stress on the cable and its connections. Sixthly, bending radius is important. The MC cable must be bent within its allowable bending radius to avoid damaging the conductors or the cable sheath. Seventhly, specific requirements for installing MC cable in different environments such as wet locations or hazardous locations must be taken into account. Eighthly, labeling is helpful. Clearly label all circuits and equipment to facilitate future maintenance and troubleshooting. Ninthly, inspection is important. Have the electrical installation inspected by a qualified electrical inspector to ensure compliance with all applicable codes and standards. Tenthly, documentation is key. Maintain accurate documentation of the electrical installation, including circuit diagrams, equipment specifications, and inspection reports. Proper installation techniques and adherence to electrical codes are essential for ensuring the safe and reliable operation of any electrical system. In the context of 277 volts high bay lighting, the selection of appropriate luminaires is also important. High bay luminaires are designed to provide efficient lighting in large spaces with high ceilings, such as warehouses, factories, and gymnasiums. Different types of high bay luminaires are available, including metal halide, high-pressure sodium, lead, and fluorescent fixtures. LED high bay luminaires are becoming increasingly popular due to their energy efficiency, long lifespan, and good light quality. When selecting high bay luminaires, consider the following factors. Firstly, the light output, which is measured in lumens, is important. Secondly, the light distribution. Thirdly, the energy efficiency. Fourthly, the color temperature. Fifthly, the lifespan. And finally, the control options such as dimming or occupancy sensing. Also, safety should always be the top priority when working with electrical systems. Never work on live electrical circuits unless you are properly trained and qualified. Always use appropriate personal protective equipment, such as safety glasses, gloves, and insulated tools. If you are not comfortable working with electricity, it is best to hire a qualified electrician to do the work.